All right, completing the square day tray. All right, so today's focus, we're going to be able to write quadratic equations in vertex form. So you're going to get it in standard form, and we're going to figure out how to write it in vertex form. So we want to write the function in vertex form and then identify the vertex. So identifying the vertex is stuff we've done before. So when we're done, it will be in vertex form. So g of x equals 3x squared minus 18x plus 7. There's two examples. This is the harder of the two, so we'll go with the hard one first, step it down for the next one, and then you'll have your own to try. So we're going to collect all the variable terms on one side. So this is a culmination of everything we've been doing. So just like completing the square, but now it has more of a purpose. So I move the 3x squared minus 18x, leave that on one side, move the 7, so subtract it from both sides onto the other. Okay. The coefficient out front is not a 1, factor out the coefficient. Alright, so we're going to factor it out of the left-hand side here. So I factor out the 3, I'm left with x squared minus 6x inside. Alright, I'm only factoring out of this side. I'm only working with this side. So I pulled the 3 out. So if I factor out of 3, x squared, factored out of 3, and then the 6x, I factor out of 3 from the 18. So now I'm going to set it up to complete the square. So what we've been doing previous days. So I'll leave my spots for my completing the square. Complete the square like we did before. Okay. So we're going to deal with b over 2 squared. b over 2 squared. So my b value is negative 6. So negative 6 over 2 squared, negative 6 over 2 is negative 3, negative 3 squared is 9. So put that back into your equation. Okay, so put it back into both sides where you have your blank spots waiting for numbers. Okay, so I plug in my 9 here. Right, when I go to plug in 9 over here, it's not just 9. The reason it is not just 9, this 9 here is multiplied by the 3 out front. Okay, so that's why I'm going to also be multiplying this 9 by 3 when I plug it in on this side. Alright, so remember, whenever you have a coefficient out here that you factored out, make sure you multiply it by the value that you're replacing. So multiply the 3 by 9 over here. Simplify that. 3 times 9 is 27. Subtract 7 from 27, you get 20. So we're simplified. Now we're ready to factor this. Alright, perfect squared trinomial. Right? Square root of the first term, which is x. Carry the minus sign through. Square the last term. Okay, so 3 stays out front. I factored my trinomial. X minus 3, the quantity squared, equals 20. Last thing to do, move the constant term over, back where it was. So back over with the variables. And then we can identify the vertex. Alright, so g of x equals 3 times the quantity x minus 3 squared minus 20. Right? This is now vertex form. I can identify the vertex from vertex form. The value in here, alright, if this is minus, it's always opposite of what you see. So you look, it says x minus 3. Alright, so it's actually a positive 3 and then minus 20. So the vertex of this parabola is 3 comma negative 20. Okay, we can check to make sure we did that right too by plugging in our x value. So plug in the 3 into the equation. So I plug in 3 where the x's were and I simplify that. 3 squared is 9. 3 times 9 is 27. Minus 54. 18 times 3 is 54 plus 7. Combine all your terms. So when I plug in 3, I get negative 20. That's what I was supposed to get because I identified that from my vertex form. Okay? These problems are just pulling together all the other stuff. A lot of other stuff we already learned. Alright, this is the harder of the two because we had to deal with this 3 out front. Alright, the next example, we don't have that out front, so it's a little bit easier to work with. So let's look at one of those. Alright, x squared plus 16x minus 12. Alright, collect the variable terms on one side, so the x squared and the 16x. And then I'm going to move my minus 12, so it was minus 12. I want to get it over on the other side here, so I'm going to add it. If the coefficient is in a 1, we're going to make it that way. Nice thing is, for this instance, it is. There is no value in front of the x squared, so we can move on. Alright, set up to complete the square. So blank spot after the 16x, blank spot after the 12. We're adding these in. Okay, now we need to find the value that goes in there. So b over 2 the quantity squared. B value is in front of the x, so we have a 16. Plug in 16 for b. 16 divided by 2 is 8. 8 squared is 64. Take that 64 and plug it into your blank spots. So this one here, I don't have a coefficient. I didn't factor anything out here, so I don't have to worry about multiplying the 64. It's just a 64 to plug in. Simplify this. You add the 12 and the 64. You get 76. All right. Completing the square makes perfect square trinomials, so we're going to factor it. How do you factor a perfect square trinomial? We've done it a bunch of times. So the square root of x squared is x. Carry the plus sign, and the square root of 64 is 8. So my factor of the perfect square trinomial is x plus 8, the quantity squared, equals 76. From here, you do the last step. You got to move the 76 back over, so subtract it from both sides. You get x plus 8, the quantity squared, minus 76. Now identify your vertex, okay? We know we get the x value of our vertex from in here, right? It's always opposite of what it appears, so it looks like positive 8, so it's really minus 8. And then minus 76. The way you can check that to make sure you're right, plug negative 8 into the original function. All right, so we plug negative in for all of the 8s, or all the x's. Yeah. And then from there, you're just simplifying. All right, negative 8 squared is 64. 16 times negative 8 is negative 128, and then the minus 12. Add everything together, or subtract everything together. You end up with negative 76, which is what we wanted. Winner, winner, chicken dinner. And there you are. That is yours. It's the only one. All right, so take your time, get it right, submit it online. Everybody's happy.